Hi, my name is Meredith, and I'm going to talk to you about how to balance chemical equations. Before we learn how to balance chemical equations, it is important to know what is a chemical equation and why do we need to balance it. A chemical equation is a theoretical or written representation of what happens during a chemical reaction. A chemical reaction is a process that involves rearrangement of the molecular or ionic structure of a substance. The law of conservation of mass states that no atoms can be created or destroyed in a chemical reaction, so the number of atoms that are present in the reactants has to balance with the number of atoms that are present in the products. So this is the reason why we need to balance chemical equations. When learning how to balance chemical equations, the first step that we should do is to write down the given equation. This given equation shows the reactants and how they yield to the products. The second step we should do is to write down the number of atoms that you have on each side of the equation. You look at the subscripts next to each atom. So for example here, this 3 is the subscript of hydrogen. And you look at the subscripts next to each atom to find the number of atoms in the equation. So here, on the left side of the equation, we're going to look at all of the atoms that are here and all of the elements. So there's nitrogen, hydrogen, copper, and oxygen. So first we're going to look at nitrogen. There's only one nitrogen because there's no subscript. And well, there is a subscript, but the subscript is 1, and it's kind of an invisible one. So you just know that if there's no subscript shown, like this one, then it's 1. So there's 1 nitrogen on this side, but on this side there's a 2 here, so there's 2 nitrogens. With hydrogen, there's 3 nitrogens right here, but on this side there's a 2 instead of a 3, so there's 2 hydrogens. With copper, there's nothing there, so you know it's an invisible 1. So there's 1 copper. Here there's 1 copper. Here there's 1 oxygen, and here there's 1 oxygen. Step 3, add a coefficient to the n on the left side to match with the n2 on the right side. So because on the left side there was only 1 n, and on this left and on the right side there was 2 n's, you're going to add a 2, you're going to add the coefficient, which would be 2, to match with that. So the coefficient 2 in front of NH subscript 3 on the left side indicates that there's 2 hydrogen atoms, just as the subscript 2 on the left side indicates that there's 2 nitrogen atoms. 2 and 2. In a chemical equation, you can change the coefficients, but you can never alter the subscripts. So here you guess and check. So here I can change the 2 to any other number or a whole number, but then here I can't change this 2 because it's a subscript. Step 4 is to balance the hydrogen atoms. You balance the hydrogen atoms by looking on the left side first. Since there's a subscript 3 and then there's a 2 here, you have to multiply them because right here there's 3 hydrogen atoms multiplied by 2. So 2 times 3 equals 6. So on the left side there's 6 hydrogen atoms. On the right side there's only 2 hydrogen atoms, so you think what times 2 can get you 6? Well, right here it says 3 times 2 gets you 6, and so since there's a 2 there, you can know that 3 times 2 gets you 6 also here. So you're going to add the coefficient 3 here to make it where it is right here on hydrogen, 3 times 2 equals 6, and right here on hydrogen, 3 times 2 equals 6. And so with that, the first step that you did was you have made 2 nitrogens and 2 nitrogens, so that works. You have 6 hydrogens, so that works. Right here with oxygen, you only have 1 because you haven't done anything with oxygen yet. But right here, you have 3 oxygen because you add the coefficient 3 here to make hydrogen 6. So you know that you're going to have to change oxygen. So you know that this isn't the final answer. And then you see that copper, there's 1 and there's 1. So you know that oxygen isn't balanced, so you're not done with the equation yet. Step 5 is to balance the oxygen atoms. The way that you're going to balance the oxygen atoms is by looking with oxygen, there's 1 here. With this oxygen, there's 3 here. You know what times 1 equals 3. You know that 3 times 1 equals 3, and you need 3 because there's 3 oxygens here. So if you put in this coefficient 3 here, you see that there's 3 oxygens here and that there's 3 oxygens here. However, because you had to add the coefficient of 3 here to make it 3 oxygens, that also made that 3 coppers, and there's only 1 copper here. So you know that you're going to have to add the 3 because there's a 3 there, and there's only 3 coppers on the side, 1 copper on this side. So you know that you're going to have to add the 3 here and you have to add a 3 here to make sure that the coppers are also equal, as well as the nitrogens, the hydrogens, and the oxygens. So through that, you did step 6, which is balance the copper atoms, and you did that by adding a 3, where here you have your final answer. You have 2 nitrogen, or the coefficient of 2 here, making it 2 nitrogens, 6 hydrogens. You have the coefficient 3 here, making it 3 coppers, 3 oxygens. Coefficient 3 here, making it 3 coppers. There's already 2 nitrogens here. There's the coefficient of 1, but you can't really say it's invisible. But anyway, 1 times 2 equals 2. And then there's the coefficient of 3 here. So there's 6 hydrogens because 3 times 2 equals 6. And then there's 3 oxygens. So that is your final answer. But you always need to remember to do step 7, which is once you check the new balanced equation and all atoms on the left and right sides are equal, then your equation is complete. So you have to make sure everything is equal. Where here we did, there's 2 nitrogens on both sides, 6 hydrogens on both sides, 3 oxygens on both sides, and 3 coppers on both sides. So as all of these are equal, then your balanced equation is complete and you have fully balanced your equation properly. Next, with problem 2, you're going to follow the same steps, except it's just a different equation. You're still going to need to balance everything and follow all of the rules. There's nothing that's changed, really. So step 1 is to write your given equation. Right here, we've written our given equation. Step 2 is to write down the number of atoms that you have on each side of the equation. So instead of everything already be written down, I'll write it down for you, or you can pause the video, write it down, and then check with my answers, whichever you prefer. So step 2, write down the number of atoms that you have on each side of the equation. So we're going to look at S first. There's only one S here. So on the left side, there's 1. Ooh, 1. But then with S on the right side, you're going to look at it. S here again is just 1. With H, you're going to look. The 3 belongs to only oxygen, not nitrogen and not hydrogen. So right here, there's only 1 hydrogen. With hydrogen here, there's multiple areas that have hydrogen, so you're just going to add them together. So right here, there's 2 hydrogen. Right here, there's 2 hydrogen. 2 plus 2 equals 4. So there's 4 hydrogen. With N right here, there's just 1 because the 3 belongs to oxygen, not with nitrogen. So with here, there's just 1. Right here, there's also just 1 because there's no other nitrogen. So right here, there's 1. With oxygen, there's 3 oxygens here. But right here, there's 1 in every place. You're just going to add them up like we did with hydrogen. So 4 oxygens plus 2 plus 1. 4 plus 2 plus 1 is 7. So there's 7 oxygens. So you can obviously see which ones are equal, which ones are not equal. So you know which ones you need to work on balancing. Step 3, add a coefficient to the H on the left side to match with the 4 hydrogens. So right here, you're going to add a coefficient here to match with the 4 hydrogens that you get from this and from this. So just ignore these for a while. You see H2, H2. That means that there's 4 hydrogens. There's only 1 hydrogen here. So what you're going to need to do is you're going to add a 4 in front of this hydrogen to make it equal to these 4 hydrogens. But then with that, that could have messed up some other elements. So you want to check again to see which ones are equal and which ones you need to balance more. So still there's 1s. With hydrogen, there's 4. There's 4 here, so that's balanced. Nitrogen, there's 4 because this 4 goes to all 3 of those, not just hydrogen. So there's 4 nitrogen. Right here, there's only 1 nitrogen, so you know that that needs to change. And then with oxygen, there's 3 here, and then there's 4. So 4 times 3 is 12, so there's 12 oxygen. But right here, there's only 4 oxygen, 5, 6, 7, and there's 7 oxygen. So you know that this one and these 2 are equal, but these 2 are not. So you still need to balance these 2. Step 4, balance the nitrogen atoms. So right here on the third step, you added the 4 there so that the hydrogens would be equal, but now that changed the nitrogen atoms. So you're going to also add, because there's 4 nitrogens here, you're going to add a 4 here where this nitrogen is, because there's no other nitrogens. And so now you're going to try to make the nitrogen atoms equal. So again, we're going to check the left and right and see which ones we need to change. So there's only one S on both sides, so 1 and 1. Right here with hydrogen, there's 4 and 4. Right here with nitrogen, there's 4 and 4. But with oxygen, it's changed on the right side. So with oxygen here, it's 12 again because 4 times 3 is 12. Right here, there's 4 oxygen. 4 times 8 is, or 4 times 2 is 8. So that makes it 12 oxygen because 8 plus 4 is 12 plus 1 more. So that means 12, 13. So you can see that everything's equal except for this one. Even though it's just one number away, it's still not equal. So we're going to have to change it even more to try to get the oxygen atoms equal. Step 5, balance the oxygen atoms. What we can do is we already had a 4 here and we already had a 4 here, but because that didn't work, you can put a 5 here, but thinking ahead just to save us time, if you put a 5 here, that means that there's 5 hydrogen atoms, but here on the right side, there's 2 hydrogen atoms and 2 hydrogen atoms. So that means you have to put a number here and a number here, and you would try to get it to equal 5 hydrogen atoms, but since 2 or 5, like the number 5 isn't divisible by 2, it's not an even number, then that just causes way more trouble than it actually needs to be. So instead, we're going to just not do 5. We're going to pick another even number. So the next number to look at is 6. So for step 5, we're going to balance the oxygen atoms by putting 6 in. So here, I put in 6 and I put in 6 in the place of 4, and we didn't do 5. So we're going to look and see if this makes them balanced. So right here, there's only one S, so that's 1 and 1. Right here on hydrogen, there is 6 hydrogen here. Right here, there is 2 hydrogen. There's only 4 hydrogen on this side, so you know that this needs to change. With nitrogen, there's 6 nitrogen here, and with nitrogen, there's 6 nitrogen here. With oxygen, 6 times 3 is 18, so there's 18 oxygen on the left side, and with oxygen on this side, there is 4, and then 6 times 2 is 12, so 12 plus 4 is 16. So we need to add 2 to this side to get it to equal 6, and we need to add 2 to this side to get it to equal 6. Oh wait, actually, okay. So then with that being said, we're going to with that being said, we're going to balance the hydrogen atoms and the oxygen atoms. So with that, you know that you need so with that, you know that you need 2 more. So right here, there is 1 sulfur, 6 hydrogen, 6 nitrogen, and 18 oxygen. Right here, there's only 2 hydrogen, and then there's 2 hydrogen here, so that means that it's 4 hydrogen, so that means that it's, 2 plus 2 is 4, so that means that it's 4 hydrogen. But if you want to change it, then you can add a 2 here to make it 4 hydrogen, so that way that you added the 2 because you added 2 to hydrogen, and you added 2 to oxygen right here. So that would be your final answer because there is 1 sulfur and 1 sulfur, 6 hydrogen and 6 hydrogen because there's 2 hydrogen here. 2 times 2 is 4, so 2 plus 4 is 6. There's 6 nitrogen, 6 nitrogen. There's 3 oxygens here, and then 3 times 6 is 18, so there's 18 oxygens total. And there's 4 oxygens here, and then there's 12, so 4 plus 12 is 16, plus 2 more, because that 2 goes to hydrogen and oxygen. That means that there's 18 oxygens total. So again, we're going to do what we did with step 1, is you're just going to check everything like we just did. So there's 1 sulfur, there is 6 hydrogens, there's 6 hydrogens, there is 6 nitrogens because the 6 goes to both. There is 6 nitrogens, and there is 18 oxygens and 18 oxygens. So you know that this is your balanced equation. Smiley face check mark. You have done this correctly. Now, with problem number 3, we're going to look at this equation. This equation is a little bit different than number 1 and 2. This equation is a redox reaction. A redox reaction is when the oxidation and reduction reactions need to be balanced just as all other reactions do, but they are more complicated. Balancing redox reactions involves balancing not only the atoms, but also positive and negative charges. Redox reactions that are difficult to balance can be managed more easily if the processes of oxidation and reduction are considered separately before they are considered together. In the half reaction method, which is the method I'm about to teach you, or the ion electron method, the redox reaction is split into 2 hypothetical parts called half reactions. The oxidation half reaction deals with all substances that become oxidized and all the electrons they lose. The reduction half reaction involves all the substances that become reduced and all the electrons they gain. So with step 1, you're going to determine which atoms have had their oxidation number changed as they changed from a reactant to a product. So you can see here that with there's 2 coppers here, there's only 1 copper here, so you can see that has changed. And then with here there's 5, or the oxidation number, there's 5 nitrogen here, there's +2 here, so you can see that oxidation number has changed as well. Step 2, write the skeletons of the oxidation and reduction half reactions. Remember that in redox reactions, one element's oxidation number goes up and another goes down. They trade charges, basically. Leo, Gur, that's one way to remember it, is Leo means lose electrons oxidation, the charge goes up, and Gur, gain electrons reduction, the charge goes down. So with these equations, that you get from the original equation, you create equation 1 and equation 2, where it shows copper and how it yields to the product, the second copper, and then how this one yields to this one. Step 3, balance all elements other than hydrogen and oxygen. You always wait until last to balance hydrogen and oxygen. So right here, there's equation 1 and equation 2, which we just showed in the last step. And you balance all elements other than hydrogen and oxygen by adding 2 hydrogen, nitrogen, oxygen, subscript 3 to the left side of the equation 1. So you added this to the left side, which is a way that you balance the equations. Balance the oxygen atoms by adding H2O molecules where needed. You balance the oxygen atoms because you see here that there's only 1 oxygen here, but you need 2 oxygens because on this side there's 3 oxygens. So you know that you need to try to balance them by adding more oxygens to the right side. So you add 1 H2O molecule to the right side of equation 2, making it 2 H2O in the equation 2. Balance the hydrogen atoms by adding H plus ions where needed. Hydrogens have a positive charge, so that's why it's H plus ions where needed. So equation 1, you're going to add 2 to the right side of the equation 1. So right here, you added 2 right here to the right side. So right here, this is left, this is right, you added 2. Right here, you add 3 H plus to the left side of the equation 1. So right here, there's the left and right side, you added 3. Because there's 3 hydrogens here, there's and then there's 2 hydrogens on the other side, so you're trying to make them even. Step 6, balance the charge by adding electrons. So electrons have a negative charge, so you're going to balance the charge because this makes them positive, so you're going to add 2 negative electrons, making it cancel out basically, and then there's 3 plus here, you're going to add 3 minus, making these cancel out. So these 2 will be your new equations, equation 1 and equation 2, and you added the hydrogen, or you added the hydrogen, which is plus, and then the electrons, hydrogen and electrons, making it positive and negative, but they equal 0. Step 7. If the number of electrons lost in the oxidation half reaction is not equal to the number of electrons gained in the reduction half reaction, multiply one or both of the half reactions by a number that will make the number of electrons gained equal to the number of electrons lost. So what this means is you're going to multiply each equation by a number that makes the number of electrons gained equal to the number of electrons lost. So here you're going to multiply this one by 3, this equation by 3, this equation by 2, making them equal to the numbers that way that they cancel out. So if you multiply this by 3, multiply this by 2, these will be your answers. On our last step, step 8, you add the two half reactions as if they were mathematical equations. The electrons will always cancel. If the same formulas are found on opposite sides of the half reactions, you can cancel them. If the same formulas are found on the same side of both half reactions, you combine them. So here, the electrons are found on both sides, so you're going to cancel the electrons, which is why they're not in your final answer. But with here, you're going to keep the hydrogens right here and right here. So you're going to take the two half reactions as of their mathematical terms. So you're going to combine this part, and you're going to combine this part into one equation, which is this one. So you can see where the pink is, that's what's combined. Where the purple is, that's what's combined. And then after you do that, you're going to combine all of them, because right here, this is the same thing, H and 0 subscript 3, these are the same things. So you're going to combine the 6 and the 2. You don't combine the subscripts. You treat them as if they're exponents in math. You don't combine them. You only combine the coefficients. So that makes it 8 H and 0 subscript 3 plus the 3 Cu. This cancels out because there's 2 on this side. So these both cancel out. And then you bring this down here, you bring this down here, and you bring this down here because there's nothing else to combine on this side. So right here, this is your final answer, but now you check it. And the way that you're going to check it is you're going to check it by looking at each of the elements. So right here, you're going to look at hydrogen first. There is 8 here, so you know that there's H hydrogen. And right here, there's only the hydrogen here. 4 times 2 is 8 hydrogen, so you know that hydrogen's correct. Right here with nitrogen, there's 8 nitrogen. Right here with nitrogen, the 2 goes to both oxygen and nitrogen, so there's 2 nitrogen. And then there's 2 nitrogen, and then you're going to multiply the 2 by the 3, so 2 times 3 is 6, so there's 6 nitrogen plus the 2 nitrogen here. That means there's 8 nitrogen, so those 2 are correct. With oxygen, 8 times 3 is 24, so there's 24 oxygen right here. 3 times 2 is 6, 6 times 3 is 18, and then the 2 goes to oxygens here, so 18, 19, 20, so there's 20 oxygens, and then 4 times 1 is 4, so there's 20 oxygens plus the 4 oxygens, which means 24, 24, that's equal. And then with the last one, there's 3 copper here, and there's no coppers over here, there's 3 coppers here. So all of them are equal, you checked, and so this is your final answer right here. Thank you for watching, and I hope this makes a lot more sense to you on how to balance equations and redox reactions. Thank you.